Now let's take a look at the implementation of one class SVM as we discuss this thing, that how to use the unsupervised machine learning algorithms for anomaly detection. So we have again our hypothetical data set over here, and you can see that it has actually divided the data set into two classes, and it also plotted the outliers over here, and the total number of errors that are being generated by the SVM are 13. Like the outliers are actually modeled as inliers. So the number of outliers that are modeled as inlier, and the number of inlier that are actually modeled as outlier actually. Similarly, we have the isolation forest, another method of unsupervised machine learning, and it works very well if we have a normally distributed data set. So what we have done is actually that the number of errors are now 6 actually in the isolation forest one. So number of errors are reduced, which we have in the one class SVM was 13. Let's take a look at our final case study, density-based method. It is well suited for high dimensional data set. So we have seen ARIMA that was actually suitable for a single dimensional. We used only a CPU feature into that. But if we have a high dimensional data set, so density-based method like local outlier factor is the best choice. Now the main idea is that the representation of the cluster in this unsupervised machine learning. So what we do is that the anomalies are actually located in the low density region. So the point where we have the the data points are available, that will be the low density area which will contain the outlier. So now all this code is already available on the Google Colab. You can see over here that we have two more density areas, and then we have the outliers which are actually on the low density area.